Hello. Hello. Hi, everyone. Good morning. Welcome to the second lecture in our series on extinctions past and present. And today we have Professor Peter Ryan, who's standing right here beside me. And some of you may know him. He's a very well-known ornithologist. He's actually the director of the Percy Fitzpatrick Institute here at UCT in the Biological Sciences department. So he's probably also a very familiar name to many of you because he's written many books about birds. So your Cecil Birds guides to birds of Southern Africa, those are several of them that Peter has written. So he's a very eminent ornithologist, and I'm sure that you will enjoy the talk that he's going to present today. So, Peter.
Thanks, Anusha. How's the sound level? Can you hear me at the back? Jolly good. Good morning, everybody. I'm sorry I missed Anusha's lecture yesterday, but I presume she told you all about the real reason why dinosaurs went extinct. So hopefully she mentioned the fact that extinction is a natural process. So more than 99% of species that have ever existed have gone extinct. It's just like death to us. It's somewhat inevitable for species. And in terms of looking back in time, as Anusha did yesterday, we have to rely on this rather incomplete fossil record. What I'm going to talk about today is much more immediate. It's to do with current extinctions, where we obviously have much better quality data and we can infer a lot more about how the process works. So welcome to the Anthropocene. For those of you who don't know about the Anthropocene, it's the era in which we live. It's the era of humans, where humans are actively changing the face of the planet. And Anusha yesterday talked about the 5 mass extinctions that occur in the fossil record, and there are people who are arguing at the moment that we're going into a 6th mass extinction, and I'm going to talk a little bit about that today. But if we're going into a 6th mass extinction, it obviously poses the question, how many species are actually going extinct? So any suggestions from the audience? How many species are we losing every year? Thousands. Millions. Okay, seems to be a certain lack of precision here. So 26. That's probably closer to the truth, or who knows. Anyway, if there's all these thousands of species going extinct, I'm sure you can just rattle off lots of examples. So let's, who wants to volunteer a species that's gone extinct in historical times, in the last 500 years? Okay, a dodo. Right, we've got a bird. Give me something that's not a bird that's gone extinct. We've got a quagga. Okay, that's a mammal. Give me something else that's gone extinct that's not a bird or a mammal. Coelacanths are still extant. There's lots of frogs. Which frog? Blue whale. There's still lots of blue whales around. And it's a mammal anyway. Come on. How about a plant? Any botanists in the room? How many plants have gone extinct? Some of them. Okay, so the point I'm trying to make is that actually it's quite tricky, and there's quite a big disparity. So this is the sort of stuff that you will be seeing in the literature when you see people saying there's thousands of species going extinct. This is something from Worldwide Fund for Nature, and it says we're losing between 0.01 and 0.1% of all species are going extinct each year, and that amounts to something between 200 and 2,000 extinctions per year. Center for Biological Diversity is a bit more bullish. It says, or not, depending on how you look at it, we're losing between 1,000 and 10,000 times the background rate of extinction, literally dozens of species going extinct every day. They also have an interesting figure on their website which says 3 species per hour and 150 per day, which kind of, if you do any basic maths, doesn't really add up. But if we go to the sort of gold standard for extinction tracking, the IUCN Red List, how many species have actually been documented to go extinct since 1500? And we just have a look at the species that are extinct in the wild and the total, for animals in the broad sense, flowering plants, other plants, fungi and protists. Any ideas as to how many you're going to see up there, roughly? Okay, it's less than 1,000 species that have been documented to go extinct in the last 500 years. So it's 2 species per year. So these figures of 20 or so per day are perhaps somewhat inflated. So how do we reconcile these sort of figures and look at the differences there? Animals, the vast majority of extinctions documented, relatively few flowering plants, virtually no other plant species, and then once we get into poorly described taxa, there's no documented extinctions at all. Just a bit of fun, which class of organisms has suffered the most extinctions in historical times in the last 500 years? Still haven't heard it. Okay, snails, the gastropods, head the list. 295 documented extinctions in the last 500 years, followed by birds, 145, mammals, bony fish, insects, amphibians, and reptiles. So it's really relatively modest. If we look at that as a proportion of the total diversity, gastropods don't look so impressive because there are an awful lot of gastropods. I think it's about 60,000 gastropods. Whereas birds, there's about 10,000 bird species, so we've killed off more than 1%, almost 1.5%. Same with mammals, 5,000 mammal species, we've killed off about 1.5% in the last 500 years. Okay, obviously once you get down to insects, it's a very trivial proportion. So why is there this huge discrepancy? People like WWF, Center for Biological Diversity, they're not idiots. How are they justifying the sort of numbers that they're saying are going extinct? And why are they so different from those reported by the IUCN? So the IUCN is an inherently conservative system. It can only consider extinctions of described species, and you need good evidence that a species has actually gone extinct. So to give you an example of that, this is a thing called Gilbert's potteroo. It's a marsupial from southwestern Australia. It was described in 1840. It was collected sporadically till about 1880, and then it was never seen again until 1994 when somebody found a little population on a hillside. So you would have been quite at liberty to say the species had gone extinct when in fact it hasn't. So these are so-called Lazarus species that rise from the dead. And one has to then be quite careful about declaring something extinct. What do we do with something like this? The Ethiopian water mouse, it's known from a single specimen collected in 1928, never been seen again. It's probably extinct, but who's actually gone and looked? How hard have they looked? Ethiopia is a big country. Maybe there's a little pocket living somewhere in some mountain catchment that we just don't know about. The other issue is, and this is really the big one, is that not all species have been described formally. So we're still describing great big hairy things like this Saoala, which was discovered in Vietnam in 1992. It's called the forest sort of oryx. In the last 20 years, we've discovered a new monkey in southern Tanzania. There's still big, nasty mammals being discovered, birds discovered every year. So if there's all of this higher level diversity still to be discovered, imagine how many invertebrates and lower sort of plant forms are still to be discovered. And so the sort of the argument that's used with these things is that many species are going extinct before they've even been described. And the poster child for this type of extinction is a ridge in Ecuador called a place called Centinela, where some botanists just happened to go and collect in 1978. And they described 90 narrow-range endemic species. And by 1986, that entire ridge had been deforested. All those species apparently had gone extinct.
Sorry, can
Technical question. I'm sure they can. Where are the controls? Sorry, I don't lecture in here ever. Is that better? So how do we cope with this level of uncertainty in terms of things that haven't even been described? So one of the sort of cornerstones of modern ecology was a theory developed in the 1960s by Robert MacArthur and E.O. Wilson. It's called the island biogeography theory, and it says that the number of species in a habitat is directly related to the area of the habitat. And so as your habitat island gets smaller and smaller, so the number of species it can support gets less and less. And this isn't a linear relationship, it's a log linear relationship. So basically, if you lose 90% of the area, you'll lose about half of the species. And this has been shown in real islands and in habitat islands in terrestrial systems. And it's one of, as I say, one of the sort of cornerstones to modern ecology. And so on the basis of this, people use the current rates of, for example, tropical forest loss and say we're losing about 1.5% of tropical forest per year, and that translates into about 0.1% of species in tropical forests are probably going extinct. We don't even know what they are. We've never bothered to describe them even, but we're losing them before we even get the chance to describe them, and that's where those numbers come from. Okay, if we go back to the historically well-documented extinctions, where have species gone extinct in historical times? Which is the number one winner for wiping things out on the planet? Country. Give me a country. Still haven't heard it. Who's everyone's favorite poster child for planet destruction? Through consumerism. North America, USA. The USA has killed more species than anybody else. 259 species have gone extinct in the US. A lot of those in Hawaii and islands off Alaska. So islands playing a big role here. But that's just for interest, that's the distribution of extinctions. Relatively few in Africa. If you look throughout Africa, relatively few extinctions. Strongly concentrated in oceanic islands, and the New World and Oceania. Can't really see the oceanic islands, but they really do come to dominate. And here's an example from birds. Of the 140 odd birds that have gone extinct in historical times, more than 90% have gone extinct on islands. And it's only in the last 2 centuries that we've managed to wipe out birds in continental systems. We'll talk more about why that is, but you can see a nice increasing trend and the great dominance of island extinctions. And just some local examples, the mascarines, Mauritius, Reunion, and Rodrigues. 32 bird species lost since they were discovered by humans. In New Zealand, lost 19 birds since 1500, but more than 40 birds have gone extinct since humans arrived there about 1500 years ago, because this doesn't even include the moas. So there were more than 10 species of moas, and they all disappeared before the Caucasian invasion of New Zealand. And the loss of moas led to cascade effects. So the largest raptor in historical times was a thing called Haast's eagle. It had a 12-foot wingspan, same size as a wandering albatross. It was a specialist on killing moas, and that disappeared with the moas. Hawaii, where most of the United States lost its biodiversity. Again, a lot of the diversity was lost even before Captain Cook sailed to Hawaii for the first time. One of the most spectacular radiations of island birds on the right there are the Hawaiian honey creepers. So from a rather boring little finch ancestor like this, we evolved all of these amazing different adaptations for pollination and feeding by probing and various other things. And if we go there now, we can't see many of these species at all. A lot of them have disappeared. This particular beast was only discovered for the first time in the 1970s. It didn't make it to the year 2000. It's a monotypic genus of honey creeper restricted to the island of Maui. One of the main reasons for the extinction of a lot of the species, or at least initially, was to do with harvesting of feathers. So the picture in the top left there shows the early Polynesian settlers in their feather cloaks. So it would take literally thousands of individual birds to collect enough colored feathers for the royalty to make their nice, pretty cloaks. A more recent example of extinction associated with oceanic islands, a single invasion of the brown tree snake onto Guam in the 1940s, probably following the Second World War, has resulted in 2 out of the 3 bats on the island going extinct, 10 of the 12 forest birds going extinct, a bunch of lizards, and so on. So why are island species so vulnerable? Why historically have we lost so many island species? The reason is that islands are these so-called disharmonic ecosystems. So the animals that live there have typically dispersed. In the case of oceanic islands, they've had to disperse over large areas of ocean to get there, and only a few taxa can do this. So the ecosystem that evolves on an oceanic island is devoid of various members that are found in continental systems. Typically mammals don't get there, terrestrial mammals, things like ants don't get there very well. And so you find this rather depauperate subset of species on oceanic islands. And the animals that evolve under these conditions don't have appropriate responses when faced with new introduced predators. So here's a picture from New Zealand showing Polynesian rat, which was actively introduced throughout the Pacific by the Polynesian diaspora because they used to eat it. They took it with them on their rafts as they traveled through the Pacific. And every island that the Kiore or Polynesian rat arrived at, it wreaked havoc through predation. So this is a little New Zealand fantail sitting on its nest, incubating. The rat comes along, and it doesn't have enough sense to actually desert its nest. It gets eaten on the nest. And we've had some problems with this in South Africa. This is a picture from Marion Island, our subantarctic island. We deliberately introduced cats to the island in 1949 when the weather base was established on Marion. Unfortunately, more than one sex was taken to the island. And by the 1970s, there were 2,000 cats on Marion. The 2,000 cats were killing almost 500,000 burrowing petrels per year. And so a decision was taken to eradicate the cats. And it's still the largest island that's had cats removed from it. This is a cat trap that was designed to funnel the cats through a particular area where they could be killed. And by 1990, the cats were removed from Marion Island. The reason why cats were taken in the first place was that sealers had introduced house mice to Marion, and the people on the weather station didn't like having little mice running around the base, so that's why they took the cats there. Since the cats have gone, the mice numbers have increased, mainly due to the climate becoming warmer and drier. And this is now what's happening on Marion. The mice are killing lots of albatrosses and petrel chicks, so we've got rid of one predator, only to have a secondary predator come to the fore. And so one of our sort of major conservation goals in the next few years is to try to eradicate mice from some of the subantarctic islands. Fortunately, with islands, one of the nice things is we have the opportunity to actually restore the islands because they are isolated, relatively discrete habitat patches. They can be restored. So this is the sort of technology we use to remove mice. Sling a bucket under a helicopter full of poison bait, fly it around the island, dropping tons of poison bait. Sounds very crude. It is pretty crude, but it is effective, and it has restored several islands already, most spectacularly the island of Macquarie, south of New Zealand, where rabbits, rats, and mice were eradicated in 2011. In the case of larger island systems like New Zealand, they can restore the little offshore islands, but they cannot, at this stage, have a feasible way of removing introduced predators from the sort of mainland islands. And so they've created these artificial habitats or protected habitat islands within the main islands by fencing them off. And this is a hugely costly exercise. This is 2 millimeter mesh stainless steel buried a meter into the ground to stop things getting back into this habitat. And then once it's suitably fenced, you can go in, remove the predators from within the protected environment, and then start reintroducing the native fauna back into this system. So much for invasive predators on islands. Don't dismiss the power of hunting. One of the examples you gave early on when I asked for examples was the quagga. It was hunted to extinction locally. The first birds to be exterminated in continental systems were all in North America. So the heath hen, the passenger pigeon, the Carolina parakeet, they were all hunted to extinction. And in the case of the passenger pigeon, it's another poster child for extinction. The numbers were absolutely unbelievable that were being killed. It was probably the most abundant bird on the planet prior to Caucasians arriving in North America. And the numbers killed were just insane. Hundreds of millions of birds killed per year until eventually it was hunted to extinction. Just another couple of poster children for extinction. The great auk obviously was hunted initially for food, and then as it became rare, so its value increased for museum collections, and the final ones were collected specifically for museums. The picture at the bottom left I particularly like. It's a mountain of bison skulls. Fortunately, the bison didn't go extinct, but it was touch and go. It got down to about 20 individuals. Very similar to the situation we have in the Western Cape with our Bontebok and mountain zebra, where they also got down into the low tens of individuals. And of course, the quagga and the blowbok living in the same area were less fortunate, and both went extinct through the power of hunting. And this introduces the interesting topic of the so-called Ice Age extinctions, or the Pleistocene extinctions that occurred around about the last glacial maximum 10 to 20,000 years ago. And people, you've all seen the movie Ice Age. You all know about how the mammoths and things disappeared. Eurasia lost 36% of large mammal genera. North America lost 72% of large mammal genera. Was this due to climate change? If we look, this is sort of a thing that maybe you saw yesterday, looking at sort of extinction rate in marine animal genera over time. We've got the 5 historic major extinction events. There's absolutely no marine signal of extinction associated with the Ice Age. It wasn't anything that happened at a global scale. It really only affected large terrestrial mammals. And it didn't all happen at the same time. So in North America, in fact, North and South America, it happened between 12 and 15,000 years ago, and we lost a whole bunch of stuff. Giant sloths, tapirs, peccaries, beavers, mammoths, bears, camels, and so on. As I say, 76% or 72% of large mammal genera. But this happened even earlier in Australia. 45,000 years ago, they lost 94% of the large mammal genera in Australasia. Well, Australia. And it wasn't just mammals, there were some big lizards and tortoises as well. And then in Madagascar, much more recently, 2,000 years ago, we lost the elephant bird and we lost a whole bunch of giant lemurs, hippos, 2 aardvarks, a whole bunch of elephant birds, and so on. So what's the common denominator here? Is it climate? Well, no, not really. What it coincides with is the spread of humans around the planet. So in Africa, we've seen relatively small impact of large mammal loss over the last few million years, whereas in Australasia, when the Aboriginals arrived 45,000 years ago, we saw this very rapid loss, 94% of diversity. In the Americas, 70-odd% loss of diversity associated with the arrival of humans across the Bering Sea, and then somewhere like Madagascar more recently. And it's interesting to see how this impact varied with human exposure. So somewhere like Africa, where humans evolved, a relatively small impact of humans in relatively recent time. Eurasia, intermediate impact, because humans moved in there fairly early on, about 1.5 million years ago. Whereas in the New World and in Australia, much more recent colonization, there's much greater loss of diversity. And just in case you don't know what humans did as they evolved in Africa, they did cause some loss of large mammals and other taxa. So around about 2 million years ago, we lost giant tortoises in Africa. We lost most of the elephants, a giant forest hippo and a ground sloth, a giant hyena, and so on. It's always the large things that go. And then subsequent to the evolution of Homo, as Homo sapiens started to evolve, or more tool-using humans evolved, we saw this steady attrition throughout Africa of a whole bunch of other things disappearing. And as people have spread around the planet, they've just caused basically more and more chaos. And one of the classic examples, of course, is Easter Island, where there's total ecosystem collapse. It went from a forested island into a depauperate grassland, and in fact, people died out as a result of the ecosystem change that they wrought on the island. So much for this myth of the noble savage living in harmony in nature. We can't go back and live in harmony in nature because we never did live in harmony with nature. We just lacked the ability to really wreck things. And now we do have the ability to wreck things. Fortunately, we also have the ability to conserve things, and hopefully we'll do the latter. So in terms of threats, what are the major threats? We've talked so far mainly about invasive species on islands and uncontrolled exploitation. But the big threats these days obviously are habitat loss, degradation, and fragmentation, mainly through agricultural production. A very large proportion of the planet is set aside for human food production. Obviously, we've transformed a lot of the environment for living space as well. We degrade the habitat through mining extensively. The oceans are being impacted through agriculture and fisheries. And I guess later in the week, you'll have a whole talk about marine extinctions, so I won't touch on that too much. The infrastructure that we put up has impacts on things. This is power line collision mortality. It's a really big problem for bustards and cranes in this part of the world. And then pollution, obviously, is a major problem. The particular type of pollution that I get het up about is solid waste plastic pollution, because of the impact it has on seabirds. So this is a North Pacific albatross chick that never got to leave the nest because its parent fed it so much plastic while it was still in the nest. Another type of pollution is genetic pollution. It's sort of a spin-off of invasive species. As we move planets around, If we move organisms around the planet, they potentially start to hybridize with some native species. This is a photograph from Sandflay in Lakeside, where you've got two mallard hybrids there. So mallards hybridizing with yellow-billed ducks. They hybridize with a whole bunch of anus ducks, and they also do even hybridize with Egyptian geese. And if you think Egyptian geese are annoying, imagine a mallard Egyptian goose hybrid. That's really scary. Of course, these days, the biggest problem or overarching problem associated with all of these threats is the specter of climate change. I love this sign. It was up on the mountain in Silvermine for a while. It said, "Please do not disturb climate change experiment in progress." Well, we'd love to disturb the experiment and stop the experiment, quite frankly. You know, it's really scary what's going on in a climate change environment. Here's just some pictures again from our subantarctic marine island. A picture from Brian Huntley in 1966, permanent ice plateau on top of Marion Island. And now there is no permanent ice left on Marion. And this is just obviously one example of the loss of glaciers around the world. Reduction in sea ice in the Arctic, reduction in shelf ice in Antarctica. Recent research from Antarctica suggests that every time the atmospheric concentration of carbon dioxide has exceeded 400 parts per million, which we did last year, the Ross Ice Shelf has broken up. The Ross Ice Shelf goes, we're looking at sort of 20+ meter sea level rise. So it's really quite scary what's lying ahead. So the thinking is it's not a matter of if, it's a matter of when we see catastrophic sea level rise. One of the things that perhaps less well known, although really quite interesting in a South African context, is the impact of carbon pollution on vegetation. So this is something that UCT scientists have been very involved in, the role of increasing carbon dioxide on changes in plant communities, in particular bush encroachment. So these are little acacia seedlings showing how root growth changes as you increase the amount of carbon dioxide in the atmosphere. So historically, before the Industrial Revolution, we were sitting down below 200 parts per million of carbon, and a little acacia seedling had a modest little root stock. We're sitting now somewhere above 400, and you can see a much more substantial root. So these plants are growing much better because they're effectively being fertilized by all that additional carbon in the environment. And that's tipping the balance, favoring shrubby vegetation over grasses in savannas. And we rely quite heavily on savannas for food production. And all of these attempts to try to manage bush encroachment, dealing with grazing and fire, they're all sort of farting against the wind, as it were, because we've got this problem of ever-increasing carbon, which is tipping the balance in the favor of the shrubs. So if we go back to the IUCN and their gold standard for extinction, they list 12 sort of major threats. And the first 7 or so really have to do with habitat loss and degradation. And then we've got invasive species, direct exploitation, pollution, climate change. And it's really only the last 2 that can be considered at all natural. Geological events, so if we have a sudden increase in volcanism, which could trigger climate change, or other threats like a meteor impact or whatever. So we're really the architects of our own demise in this situation. Most of the impacts are human-related. Interestingly, the one that's not there at all is probably the most important one, which is human population growth and associated increase in consumer demand. So the current estimates suggest that we need 1.4 Earths to support the demands of the human population. So we're already exceeding the capacity of the Earth to support ourselves. We're eating into the future capital, and that's clearly not a recipe for sustainability. Okay, I've got sort of 15 minutes left. I'll just talk a little bit about estimating extinction risk and predicting extinction. So you've probably come across terms like threatened species, endangered species, vulnerable species. What do these terms actually mean? These are all formally defined now. The concept of a red data book was really started in the 1960s, and it was done on a taxon by taxon basis. People got around and they said, okay, you're the experts on birds. Just kind of, from your knowledge, which ones do you think are really likely to go extinct? And we'll call those critically endangered, and which ones are pretty likely to go extinct? We'll call those endangered, and which ones are not quite so likely to go extinct, we'll call those vulnerable, and so on. But there was no real attempt to make this objective or comparative between taxa. So you had different groups of experts for different taxa, and everybody did their own thing. Towards the end of the 1980s, when conservation biology was really getting going as a discipline, there was a call to try to make this a more sort of objective and repeatable exercise. And so these categories were much more formally defined. And in the height of the sort of population viability analysis era, there was this concept that we would be able to actually estimate the extinction risk associated with each species and put it into categories on the basis of an extinction risk. So the idea was that a critically endangered species has a 50% chance of going extinct in 10 years or maybe so many generations, because it's a little bit tricky if you've got something that lives for 100 years. Obviously, it's quite difficult for it to go extinct in a 10-year time frame. So you can have a generation thing, but let's not worry about that too much. Endangered was a 20% risk of extinction in 20 years, and vulnerable was a 10% risk of extinction in 100 years. You've probably gathered from the way I couched that terminology, this is really not the way things are done anymore. We cannot realistically estimate the extinction risk for populations. It's a hugely data-demanding exercise, and even then, it's ultimately extinction is a fairly stochastic event. So sometimes things will get very small in numbers and they'll still recover, and other times things will just disappear for seemingly no obvious reason. So what are the major predictors of extinction risk if we go through this exercise? If we look historically, body size is one of the better predictors of extinction risk. So if we look at the Pleistocene extinction, the median body size of animals that went extinct in the Pleistocene, bearing in mind the biases associated with preservation of evidence, basically it was large animals that went extinct in the Pleistocene. Median body size, almost 200 kilograms. Species that have gone extinct in the last 500 years, this is animals obviously, have a median body size quite a lot smaller than that. Currently threatened species, still smaller, and least concerned species, all the small species. So if you're small, it's good. Unless you're a human, then it's also good. So what's going on with body size? Body size correlates with a whole bunch of things. Home range, typically, and also population size. And really the best predictor of extinction risk is, the single best predictor is population size. And so there was a whole school of sort of a holy grail for the early conservation biologists to identify the minimum viable population size. How many animals is enough to ensure that there's a reduced risk of extinction? And that soon came to naught because there isn't really a single answer. And in fact, Graham Corley, an Australian biologist, said we really need to think about extinction in two different ways. So we have a declining population paradigm. So typically things start off with reasonably healthy, large populations, and some external driver starts to impact them, whether it's competition or exploitation or pollution or invasive species or whatever the case may be. And that pushes this once large, safe population into a small population. And once you get down to a small population size, you move into this entirely different paradigm, the small population paradigm, where it doesn't really matter so much if you remove the external driving forces, there's still a reasonable chance of extinction just because of bad luck. So you move into what's known as the extinction vortex, and this is just one representation of it. You can see here how as the population gets small, so it starts to have inbreeding, it loses genetic diversity through random drift, which causes the population to be less fit effectively, produce fewer offspring, so the population gets smaller, and so you start to spiral down into ever smaller population size. And with smaller population size, ultimately what tends to happen is you have some environmental event that drives the population extinct, bad luck, a drought or a flood or a catastrophic fire. And those kinds of things aren't a problem if your range is across sub-Saharan Africa. But if your range is confined to 1 hectare of the Cape Peninsula, then it can be obviously quite catastrophic. There's a taxonomic signal associated with extinction risk. So it's not a great figure, I'm afraid, for those of you at the back, but just to see that, obviously the red bars here are proportions of extinct, critically endangered, endangered, vulnerable, and so on. Green is least concern. The gray bars are data deficient, which is another category which is very problematic, where we don't have enough information to decide what the conservation status is of a taxon. But here we've got cycads showing this terrible profile of 60+%. are threatened species. Amphibians not doing very well, moving through a whole bunch of things, through birds where you've got about 20% threatened, right down to lobsters where there's virtually no threatened species. So there's a taxonomic signal associated with extinction risk. And the extinction risk within a taxon changes over time at different rates. So birds and mammals, which attract quite a lot of conservation funding, are not showing particularly dramatic decreases in their conservation status over time. So this is comparing successive editions of the red list. Whereas corals, which all of a sudden have become under threat due to climate change, coral bleaching associated with rising sea temperatures, a very severe decrease in conservation status of corals, amphibians showing an intermediate trend, mainly associated with that chytrid fungus. What are some of the problem areas at the moment? Top predators and scavengers. We're having a real problem in Asia. There was a massive problem with scavengers through accidental poisoning. So diclofenac, the anti-inflammatory that was given to cows in Asia, is very toxic to vultures and virtually wiped out vultures throughout Asia. Just this year, or the end of last year, virtually all the African vultures were put on the threatened list. So we now have, stand to be correct, I think 2 critically endangered and 3 endangered vultures in South Africa. And that's through deliberate poisoning, accidental poisoning, persecution, collision mortality, a whole bunch of things that are affecting our scavenger population. Taxa that rely on multiple habitats are also more likely to go extinct than taxa that are confined to a single habitat. So seabirds, they face threats both at sea and on land. We talked about some of the land threats associated with introduced predators, but at sea they're getting caught on fishing lines or competing with fisheries for food. Migrants, a really strong signal in southern Africa is the disappearance of migrants. When I was a child growing up on the peninsula, the white-winged tern was super abundant somewhere like Strandfontein, 20,000 individuals, now there's none. So these birds that are breeding in the northern hemisphere and traveling down to southern Africa for our summer are disappearing. These curlew sandpipers, still the commonest shorebird in South Africa, but the population in the Western Cape has decreased by more than 90% over the last 30 years. Why are migrants so at risk? Here's the poster child for extreme migration, the bar-tailed godwit. The Pacific population does the most extreme flight of any organism on the planet, flies from Alaska to New Zealand non-stop, takes about 8 days, 11,000 kilometers. Doesn't drink during that time, pretty impressive. I bet Tim Noakes would have something to say about the likelihood of that. And then after spending the summer in New Zealand, it flies back to the Yellow Sea. In China, the Yellow Sea is disappearing at a rate because the Chinese just keep reclaiming larger and larger chunks of it to turn it into rice paddies. And then a short hop back to the Alaskan breeding grounds. So that's the most extreme migration in terms of shorebirds. Most of the smaller shorebirds, well, in fact, all the other shorebirds don't do anything quite as extreme as that. They have multiple stopover points. And it's like a sort of a weakest link in the chain situation where each stopover point is essential. If the population arrives and the habitat's been lost, they cannot refuel to carry on their migration. And so again, look at something like sandling, the little run up and down the beach in flocks, used to be common sight on the West Coast beaches. They're still there, but down 90% in the last 30 years. Really quite worrying how these birds are going places. In terms of terrestrial systems, we're not having a lecture about freshwater systems, but freshwater systems are basically islands in a sea of land. So just as oceanic islands are the most threatened terrestrial systems on the planet because they're so susceptible to invasion, so freshwater systems are the most susceptible terrestrial systems, if you like. They're obviously not terrestrial, but they're little islands in a sea of land. And so we have things like all of our endemic fish in the Western Cape are being hemmed in by introduced predators, which push them higher and higher up into the headwaters. And unless we go in and do some active restoration of those areas by removing the introduced predators, we're going to lose these very intriguing and ancient lineages of freshwater fish. And this is just to reiterate the importance of freshwater systems or the threats facing freshwater systems. So the last 40-odd years, just tracking the sort of health index, if you like, and you can see that freshwater species are faring worse, much worse than terrestrial species, with marine sort of tracking a little bit below terrestrial most of the time. And then really worryingly, it's not just the big and hairy things that are disappearing. Common species are also at risk. Now, we don't generally have much data on this. It's only in really depauperate places like the UK where people actually bother to track things like dragonflies and grasshoppers and things. But the data coming out of the UK are showing consistent decreases in invertebrate taxa. And there's sort of anecdotal evidence that this is happening, and I'm sure many of you in this room will recognize, if you've lived in an area for a long time, how things are becoming less common. Things that were common are just becoming less common. So what are we going to do about all this? Unfortunately, the resources available for conservation are not sufficient. One of the approaches that's been pushed very strongly by Norman Myers and a bunch of other leading conservation biologists is the concept of biodiversity hotspots. It's particularly important for South Africa because we're the only country in the world with 3 biodiversity hotspots. It only shows 2 on that map, but there's now a Ponderland center of endemism as well. There are 25 global terrestrial hotspots. This is a terrestrial sort of approach, but that suggests that if we can just conserve that 1.4% of the Earth's land area, we could potentially conserve almost half of the plants and about 1/3 of the terrestrial vertebrates. And the cost to do so is trivial compared to what we spend on things like defense and other silly things. And it's also trivial relative to what we value in terms of ecosystem services, which are derived from natural systems. And there's a figure, there are people who do this for a living. They thumbsuck numbers out of the air. $76 billion to conserve all biodiversity. $76 billion is really not a lot. And probably the top 10 individuals in the world could do that out of their bank balance. There's a horrendous statistic recently. The top 60 people in the world own the same as, I think it's about 3.5 billion people at the bottom of the money pile. It's insane. Okay, we're running out of time. In terms of triage, we also can target our conservation efforts depending on the value of species. And so how do we decide which species are more important? So some species play essential roles in the functioning of ecosystems, so-called keystone species or ecosystem engineers. We can also use species as umbrellas or flagships for conserving entire systems. So you might say that conserving giant pandas is a waste of time, but by conserving giant pandas, we conserve the bamboo forests associated with them and all of the other taxa that live in those bamboo forests. Lose the panda, we'd probably lose the remaining habitat. And then there's an interesting concept of phylogenetic diversity. So we shouldn't just be worrying about numbers of species. We should be thinking about unique lineages which represent these sort of very, very different types of animals and plants that live on the planet. And there's quite a nice group that's started up in the last few years called the Edge of Existence program. EDGE stands for Evolutionary Distinct and Globally Endangered Species. And so what they're doing is they're saying, okay, we want to look at the species that face a high risk of extinction, but which are also phylogenetically very distinct. So something like the aardvark. There's only one aardvark left. Okay, there were some that we wiped out already, but we should put more effort into conserving the aardvark than we should put into conserving the riverine rabbit, because there's quite a lot of rabbits in the world. If we lost the riverine rabbit, it wouldn't be as big a loss as if we lost the aardvark. So they have a top 100 species of mammals and birds, and they've even gone on to look at the cost associated with conserving each of those species, so they can have sort of an economic return for phylogenetic conservation. And I'm just going to leave you with this final slide, linking back to hopefully Anusuya's lecture yesterday. These are the extinction rates that happened during the big 5 extinctions, so the Tertiary Cretaceous, Devonian, et cetera, et cetera. This is where we're currently sitting. Let's try that little pointer. This is the already extinct species. If we lose all of the critically endangered species, this is just looking at birds, mammals, frogs, and snakes, that's where we'll get to. If we lose all threatened species, that's where we'll get to. And the sort of idea is that if we carry on pushing along this curve, that's the justification for why we're going into a 6th extinction. So it's not a very happy story, I'm afraid, but that's it for the morning. I'm happy to take questions if you want to ask any. Thank you. Do the lights. Oh, it's here. Oh, well done.
What does IUCN
It's the International Union for the Conservation of Nature. I think they've changed their name now, but they still keep the same acronym. You know, it's all about branding these days.
What is this?
Yeah, I'm not fully au fait with where it's at. What was done with the quagga was fairly early on when people started doing genetic sequencing in the 90s. Eric Harley from UCT Medical School got some bits of skin from some of the old quagga specimens, looked at a relatively small section of one gene, said it was identical to the plain zebra. On the basis of that, they're the same species. We can recreate the quagga by selective breeding. Whether anybody has done any really good genomic analysis to see whether that really is true, you know, looking on the basis of a fraction of one gene is not really a very robust way of assessing whether or not they really are the same species or not. But you know, we can select for, and they are selecting for, basically just an artificial selection process to get things that look like quaggas. Whether that satisfies you that we're recreating the quagga or not, personally, I'm not convinced. You know, in future, it might be conceivable to actually try to do some genetic engineering, artificial, you know, sort of cloning type technologies to try to bring back species using fragmentary DNA. But you know, you have to understand that when people start working with ancient DNA, that the DNA is pretty badly degraded. So you can't like get an entire genome and just plop it into an egg and expect it to grow. So it's not that science fiction-y, I'm afraid. I think hunter-gatherers lived closer to some kind of sustainable balance, but again, it's because they've already weeded out the things that were easy to kill. So the ancestors of Bushmen, you know, 500,000 years ago, took out the things that were easy to kill. If you'd taken a Bushman and put them on Marion Island, they would have completely trashed Marion Island in probably one generation. So it's a matter of finding a balance. And when you introduce a new predator into a system, it finds a new balance. And we've been living in Africa for 2 million years, and so the system looks reasonably stable. But if you take those Bushmen and put them into you know, take them to Australia, which is what happened 45,000 years ago, effectively catastrophic extinction. I don't want to be too gloomy. I think, you know, so obviously there's a lot of clever people trying to work on this problem. We are reducing the amount of materials we use, so everything can be done with less these days. So there are positives and negatives, but we have to grasp the nettle of human population growth at some stage, and we have to tackle the sort of the macroeconomics people who want, you know, 5–10% economic growth per year as the way that we do business, because we can't continue to grow economies at 5% or even 1%. We have to live within the limits of the planet. We're already exceeding the limits of the planet. Oh, go ahead. Probably cycads, pretty high there. We've lost some, and we're probably going to lose some more. They're effectively extinct in the wild, a lot of taxa. Yeah, I don't know, I'm a bird person, but I wouldn't pick a bird. There are lots more other things. So some of the fish taxa, you know, they're restricted to very small patches. Some of the plant taxa, again, small population size is the real problem. And so wherever you've got things that are really constrained. I mean, we're sitting in Cape Town. The metropolitan area of Cape Town has the highest proportion of red-listed species of any metropolitan area in the world. So we live right at the coalface of conservation here. We have an extraordinarily kind of good bunch of people working for the city to try to conserve in the face of pressures for development. So, you know, they don't actually get the recognition. Julia Wood and her biodiversity department in the city do an amazing job, despite all sorts of impediments put in the way by their political bosses. Sorry, I'm not. I am avoiding it. I think if the endangered species is still, if it's still extant, if it hasn't gone extinct, I think, yeah, cloning is one option, cross-fostering, there are a whole bunch of options, captive breeding, all of those sort of extreme ex situ conservation efforts are really last ditch. I think I wouldn't put public good resources into them because I think they're more sort of vanity exercises. We should be trying to conserve functioning ecosystems. If they're keystone species, maybe we can make a case for it. But just, for the sake of, if we lost lammergeiers from the Lesotho, which is very likely unless we stop wind farm developments in Lesotho, even if we don't stop wind farm developments, even if wind farm developments are stopped, probably still going to go extinct anyway. Is it really worth putting 10 million rand a year into a captive breeding program to try to bolster the population? I'm not convinced personally. But if some individual wants to put their money forward and do that, I'm not going to say no. It's better than nothing. So.
What is the estimate?
I guess, I don't think there's a single number. It depends very much on lifestyle. So we could probably support as many people as we have now if we lived very different lifestyles.
Some conservationists and politicians, in fact most of us, are avoiding thinking.
Yeah, there's a really interesting book called Requiem for a Species, which I can recommend if you want to really depress yourself. So it's written by an Australian sort of philosopher, think tank kind of guru type guy. I can't remember his name, but if you just Google Requiem for a Species, and it's focused around climate change and saying, we know that this is coming. It's this like hurtling train coming towards us, and we stand in the track looking at it. Why aren't we doing anything? And he examines that sort of inability to deal with things, the lack of immediacy. If it's not like really about to hit you, we'll just put our heads in the sand and carry on business as usual. Read the book and it'll explain it better than I can. So there's one. Yeah.
I just wanted to ask you, do you know?
Yeah, in South Africa, it's very much a hot potato. In the sort of 80s and 90s, there was a really active, or relatively active group. I can't remember the woman who was in charge, who was actively lobbying government to try to do something about population growth. But it seems to have just dropped off the political agenda entirely. It's just too sensitive an issue. It has racial and societal, socioeconomic kind of undertones that people are not prepared to deal with. Yeah, the conventional wisdom is if you educate women, empower women to make choices and so on, it certainly helps, but it's not helping fast enough. Yes. Yes. So there's lots of issues. Any new technology has pluses and minuses. So relative to coal-fired power stations, wind farms are wonderful, but wind farms do kill black eagles and large raptors in particular. Vultures and eagles are particularly prone to being killed by wind farms. They just fly into the blades. The tips of those blades are moving so fast you don't realize. The damn things are so long. They're going around, looks really slow, but the tip's moving like 180 kilometers an hour, and you have to go and YouTube it to see. These birds are just flying along and suddenly bang, that's it. So it's quite scary. And things like, fuel oil, sustainable, the whole push to have biofuels is causing massive forest loss in Southeast Asia for palm oil planting. So one has to be really careful how you implement these so-called green solutions.
One of your slides, it seemed to me that the lobsters
No, so I mean, so the South African rock lobster, yes, obviously it's an attractive resource. It's nowhere, it's not listed as threatened, although it probably would qualify through some of the IUCN criteria as threatened. The West Coast population is not healthy, but like many of our Benguela species, it's moving onto the South Coast, and in places around sort of between Cape Point and Cape Agulhas, its population has massively increased, so it's actually doing okay down there.
Will mankind become extinct?
I think it's a good point to cut the questions, isn't it? I don't know. Okay, there's no easy answer to a question like that. I suspect it'll be more with a whimper than a bang, but you never know. Somebody might get silly and do something really rash. There's so many things that could happen. It's impossible to say. So already we're seeing. Through the 1900s, post Second World War, we've seen a steady increase in the quality of life for people, and that peaked around about the end of the century, and since then it's been stabilizing and going down. I just foresee that trend continuing, and climate change is going to exacerbate it. So things are going to be really interesting for you guys, and old farts like me. We can sit at home and watch it all happen on TV, but for the younger generation, it's really a scary world we're going into. People's ability to travel and do things that we take for granted are going to become constrained. Food security is going to become a massive issue. There are all these problems with health, disease-resistant bacteria and all the rest of it. So all the stuff that we take for granted now is going to be slowly eroded. Whether it'll lead to extinction, I don't know. We're a resilient bunch. We'll come up with a solution of sorts. But, it's going to be a very different world 100 years from now. I think the sea level will be a lot higher, the climate will be a lot warmer, there'll be extreme storms. All of that's in the pipeline. Even if we change what we're doing, the best science at the moment says we're headed down that track, and there's not much we can do about it.
Haven't listed atomic war.
Yeah. Again, I don't think sort of even a really bad atomic exchange would wipe out people, but it would greatly reduce the population. Another fun book, if you want, there's this good old boy called Gwyn Dyer, I think his name is. He's written a book called Climate Wars, which looks at how climate change is going to increase global tensions, and he has a whole bunch of scenarios, starting with Pakistan, India fighting over meltwater from the Himalayas, how that's going to trigger, potentially a regional thermonuclear exchange, right through to Canfield Ocean, so the whole ocean becoming anoxic and killing off everybody in 200 years' time. So another fun read if you want.
Let's go for one more question.
Oh, there you go, done.
Very good note.
Such as it is.